Hello everybody. Hello, how are you all doing tonight? Well, hopefully it's not going to throw people off that we had a class last week and we have this week. This is the normal week that we would have a class. Last week we just did a special class to finish up part 2 of that 3D modeling class that was a big hit with everybody. Tonight we are going to have kind of a montage of different things, short to the point tips and information on some viewers' choice items. I put out posts on Facebook. I didn't put any post out here on YouTube. Just put it out on Facebook in 3 different groups and ask the viewers what are some of the struggles that you have with the Vectric software. What are some of the topics that would make you more proficient in the software? Where do you need help in the software? And I asked those 3 questions to kind of get some answers back on what type of topic I could talk about that would be helpful to people. And so there were quite a lot of different responses. One was VCarve inlaying. The other was VCarving a complex project, like a flag with detail or designs in it, like a emblem or something. 3D resolution, dealing with smoothing and draft on a low resolution model or resolution in general. We'll talk about resolution so you understand what I referred to. It's basically the pixelation in the model. VBits and feeds and speeds, how to stop the whine of the bit and things like that. Photo V carving. So there was a lot of different responses, and so what I'm going to try to do is systematically go through each of those things and give some brief tidbits or topic information and tips and stuff and whatever it comes to be, and we'll see how far along we can get. The other one was VCarve inlaying. We're definitely going to be talking about that tonight as well too. So welcome to everyone, and hopefully the crowd grows as we get into this, and hopefully you all are pick something up from it, right? Okay, so with that being said, let's get over into the software. And in the software, I am on camera 2, and I need to move myself down here, and let's see if we can do something with that. All right, now I am going to be working across VCarve Pro and Aspire. I'm not working in desktop, but everything that I'm doing can be done in Desktop Pro and Aspire. There's only going to be a certain features, drafting and stuff like that, that's an Aspire feature, and when we get to that, I'll let you know that, hey, this is only Aspire. But everything else is going to be Desktop Pro, Aspire compatible, all of it, and everything. Okay, so Wade, I'm just reading a comment on one of my customers. I create a lot of small items. Let's say there's 100 things on a sheet. I have to individually select each item to get the machine to go from left to right and then from right to left on that item. Well, I think depending on what what type of carving and cutting you're doing and everything, number one, your start at and your the order that the vectors are carved. They're either going to be carved in the shortest path from your start point. They're going to carve in the shortest path to optimize your feed, your runtime basically. or they are going to be starting and carving based on the vector selection order that you have created, or they're going to start based on the start point in node editing on a design. So let's say that in this example, we'll start with Wade's question because it's a good question and it's a good starting point. Let's say that I have a project that is 24 inches by 24 inches by 3/4 as far as the sheet goes. Let's say that I'm going to be starting on the material surface, touching off on the material surface and starting from the bottom left corner, and I'm going to click OK. Now, I'll just draw a star here. We'll go with a 5-pointed star. Let's go 38.2. We'll talk about that in a moment too. And let's move that down here. Now, when I create an array or a copy of things, let's say that I'm going to do 7 rows and 7 columns, and I'll do a gap in between each one of about 3/8 of an inch, and we'll copy that. So let's say that these are our items. Okay, everybody with me so far? Good. All right, now number one, I'm going to move these over here for a minute. Number one, I want to minimize my waste and maximize my yield to the best of the ability when I'm cutting parts out and things like that. So I'm going to nest these individual items onto my material. And each of these items, if I were to go into node editing, they each have a start point. Now, depending on where I want the item, if I want it to start on its start point, then my bit's going to go from start point to end point, from start point to end point, so on and so forth. If I tell the tool path, the profile tool path or what have you, that I want to go from the shortest distance, then it's going to go from, you know, left to right, bottom to top, and it's just going to do the shortest path to get everything done. If I tell it to do the vector selection order, then I'm actually physically going to select each vector in the order that I want it to carve. If I want it to carve in this order, come up here and then come back and carve this and back and carve this back and forth and everything, I need to select them in that order. And I need to choose in the tool path when I'm looking, especially like on a profile toolpath, down here in order, I'm either using the vector selection order, or I'm going from left to right, or I'm going bottom to top. I'm doing a grid pattern, or the shortest path. Now, if I check off all these boxes, or one of these boxes, or some of the boxes, it's going to do exactly that. Now, as far as my start at, if I optimize the start points, that means it's going to whatever the closest point to get from one object to the other, the shortest path to keep the runtime down, whatever point it is, it's going to start at that point, not necessarily the actual start point of that object. If I tell it to keep the current start points, you can see the start points light up over here when that's checked, then it's going to start on the start points of those objects. And I can put the start, before I make my copy, of course, I don't want to do it one by one, but I can, in node editing mode, I can put my start point anywhere that I want. I can insert a point here and I can make that the, hold on a second. I can make that the start point, right? If I wanted to start there versus inside of that crease and stuff, I can specifically put the start point where I want it to be. So in the case of this, it really just depends on what options you choose, and it depends on what pattern that you're wanting to go. Now for me, they're specific when I'm surfacing I use the vector selection order. I want that bit to cut in a certain order. When I'm carving parts out, hey, the shortest path is great, right? Whatever cuts the runtime down. Whatever it takes. Now, when I'm nesting these parts and everything onto the material, the nesting, I will specify the bit that I'm going to be using. In this case, I'll use a small bit, like an 1/8 inch end mill. The clearance, how much clearance I want from when the bit is carving one part, how much clearance is left behind that bit to the next part. That's what the clearance is. So if I have, let's look at that in detail. If I have a part that I'm cutting, and let's hold down the control key and drag this over here. And I have my bit cutting. Let's say my bit is cutting up against the edge of that wood. And we'll move this over a little bit. But the clearance is the distance from the back side of the bit to the next part. That is the clearance when in the nesting toolpath. That's the clearance. So when I am nesting, and we'll move this up here in case I need to refer back to it. When I'm nesting these parts, if I'm using an 1/8 inch end mill, the clearance I'll set, however much I want. In this case, I'll go 3/16. 0.1875. Give me a little bit of meat left over so tabs and stuff can stick to it and all that stuff. Because you got to remember, because when the bit carves on the other side, right, whatever's left, that's the meat, right, in between. In the border gap, how far I want to stay away from the border. Now, of course, this is not going to fill up my whole board. It's only going to fill up a very small section. So I can either nest the parts, keeping them vertically, like if grain is if I need the grain running the same direction on them and everything, I can just nest them to where it'll try to nestle them together. Or I can rotate the parts for best fit. For me, I like a little bit of design difference in the parts and stuff as far as the grain direction and things. It's not going to hurt it. It's nothing structural. I'm cutting out a bunch of stars. Right? So I would rotate, and I would allow it to rotate in 10-degree increments or less. I could go 1-degree increments, right? Whatever works for best fit. So my increments, in this case 10 degrees, it'll allow it to rotate in 10-degree increments until it snuggles in and fits where it fits. I do not want to mirror the parts because usually, like if I'm cutting out a plywood or something, usually there's a good face and a bad face. I got the good face up, so I don't want to mirror the parts and have the front of one of my parts facing down, right? So I don't want to mirror the parts for best fit. I don't want to allow the parts inside another part because they're not big enough to fit inside. I have no part that I'm cutting out where there is waste inside of that part. Think of if I was cutting a ring out, that centerpiece is waste, and I could allow a part to fit in there if it fit, right? But I have no situation like that, so I'm not going to check that. And I'm going to remove the original parts I created and just have it redraw the nested parts and everything. I'm going to nest from the bottom corner up. I could go from any corner. If I only have a certain area on my piece of plywood or whatever, a piece of wood, let's say I'm carving out another project and I have all this area over here, but I can define an area and I can have it nest inside that area. So, I'm kind of utilizing as much waste as I can, right? So that's the nesting boundary. I don't want a nesting boundary in this case. So I'm going to go ahead and do one copy of each on the active sheet. I'll click preview and I'll let those parts rotate for best fit to minimize my waste, maximize my yield. Now each of these, because there's rotation and everything, the start points, they're all in certain positions and different positions and all. So it's very important that when I'm cutting these parts out, let me select those. In my tool path, I'm going to cut through my material. I'm going to use an 1/8 inch end mill on the outside of the line, and when it comes down to my order, this is important. Do I want to go the shortest path? Do I want to just use, I want to select all the vectors in a certain order and make it carve in that order? Do I want to go from left to right, bottom to top, whatever, right? So if I have all 4 of these checked, it's gonna follow that method. It's gonna go shortest path, working from the bottom left to the right, and bottom of the board upward. So all of those things, it's going to try to optimize that cut in that order. If I have just the shortest path, it's going to pick the shortest path from my start. If I go left to right, if I go bottom to top, all of that stuff. So it really depends on what you've got selected. So in this case, I'm going left to right, bottom to top, grid, and shortest path. And I am going to not keep the start points. I'm going to optimize the start point so it is the shortest path. So it'll go from one side to the other and click, and I'm going to calculate that toolpath. So when we preview that cut, it's going to make the cut and then move to the shortest path all the way to optimize, you know, that cut. If I were to have told it to keep the start points and calculated that, then it's going to go over to each of the start points on the design, every single one of them, right? So Wade, I'm not sure if that's what you were trying to I'm not sure if that's what you were trying to get at with the comment and everything. Sorry about the blur on there, guys. Turn up your resolution. There's a little thing at the bottom of your screen if you're getting a little blurriness. But I'm not sure if that's what you were getting at, but when you're cutting out or when you're cutting parts and everything, there are options that you can choose. And if you're not seeing those options in your toolpath, that means you have the show advanced options turned off. Without that checked, those options aren't there in the toolpath. So with them checked, it shows all those advanced options and things. All right, cool. Yep. All right, so so Wade, I hope that answered. I hope some of that was I don't know, was helpful to the comment that you were selecting, but that's where you're at. Now, when it comes to other toolpaths and everything, the only options, as far as advanced options like that you have, are use vector start points, and by default it's unchecked. Use vector selection order, by default it's unchecked. So if you need to carve a VCarve, in this case I have open, if I need to carve a certain vector selection order, then I need to select those vectors in the order I want to carve, and I need that checked. If I want to use the start points and have it carve, on each of the start points of the projects, then I need that checked. If those are unchecked, then by default it's going to do that shortest path, bottom to top, left to right. It's gonna find, on a VCarve, if you ever watch your machine, like it's jumping around, it's literally going, it's kind of doing all the deep parts first. It's doing all the deep cuts first. It's jumping around and doing all the deep pocketed areas of the VCarve. It's doing that first, and once it gets done, then it comes back and starts doing all the detail work. And the detail work, it's finding the shortest path. It might carve half a star and then jump to another star and another star and then come back and finish the other half based on what it feels is that, that shortest path and everything, whatever is, optimized and stuff. And depending on, what you choose depends on kind of what it'll do and everything. Right? All right. So, yeah, let's go on. Let's move on to that. So hopefully Wade, sorry, that was helpful to you in some way, as far as, how to, when you have bunches of items to carve, getting the best time and performance out of that. All right, let's delete this and this. Okay, now we're going to start off with VCarving. And like I said in the beginning, for those of you who just joined and stuff, welcome, first of all. Hey, Mark, Lindsay, how you doing? Brooks and everybody. There's Troy in there too. Big Daddy Fish, how you doing, man? The subject matter that I put out, the post I put out said, hey, tell me where you're bottlenecking in a sense. I didn't use the word bottlenecking, but where are you struggling from, where you need help with, and what would make you more proficient. And like I said, there was lots of topics. There was V-carving, complex designs, V-carve inlay, which we're going to talk about. We're going to talk about those two things. 3D resolution, dealing with 3D resolution and drafting a 3D. We talked a little bit about that, quite a bit, on the parts we made for the Sheriff's Badge, the last two classes, where we did some drafting on the parts, you know, to give it a little bit of angle and everything. And drafting, the term drafting generally, you know, revolves around parts that fit into one another. So like a injection mold, the mold itself will have a little bit of a draft angle, so when the mold comes apart, the part comes out easier and things like that. Well, in this case, it's the same thing. It's so, you know, the bit carves, you know, a lot easier instead of having to stop and raise up and all. We're going to talk about that. They were talking, you know, we had somebody that was wanting to know about speeds and feeds and bits and things. So we're going to progress through, and we're going to start off with simplest to more kind of complex, I guess. It's not really complex, but, you know, more stuff. And we're going to start off with V-carving. Okay? So, if any of you have been following along in the classes and things, you know that there was a couple classes back where we did these kind of state pride project where we had these states cut out with the American flag in there. And in that video description, I provided a file of all the states and 2 American flags, right? The customer that, or the viewer, the viewer that asked about, you know, carving complex designs and stuff, he was referring to, he said, you know, specifically flags with designs in it. So we're going to kind of do a little bit of a flag design with, we'll use the vector of the star badge we did last week, and that'll be kind of the emblem in the flag. And it's going to be just a flat flag, a V-carve flag, no waves or anything like that in there. And we're going to utilize those vector files that are free for download in that State Pride class like 3 or 4 weeks back. Okay, so we're going to go with a project that is 38 inches by 20 and 5/16, 3/4 inches thick, touch off on the material surface and bottom left corner. That's going to be our setup for this. Now I'm going to import a vector file, and on the vector file that I'm going to be importing, we're going to import the flags. Let's see here. We've got, if things don't get disorganized on me, 4th of July 2023. It's not there. And of course I'm looking in the wrong, we're going to import not an image, a vector, ladies and gentlemen. Import a vector. That was the wrong button. I pushed the wrong button. So let's try that again. Let's go back and let's see here. 4th of July. Oh. U.S. flag proportions. All right. Now, we're going to do the standard American flag, not the 1776 Betsy Ross flag. And by default, this flag is imported. It's called flag proportions, the file name. It's a DXF file because it is proportionally perfect per the Constitution requirements and everything of the flag. And it can be sized up or down, scaled up or down. Don't stretch it. you know, keep the proportions, keep the aspect ratio and everything. But to start off with, by default, it is 38 by 20 and 5/16. Okay. Now, with this flag, the stripes, the vector rectangles for each of the stripes is in here. Now, typically, we don't use the red stripes as far as we don't carve them. Typically, they're raised up if we're doing a V-carve flag, and the white stripe is carved down, red stripe is raised up, white stripe is carved down. So what we're going to do is we're going to select on this flag, we're going to select every other vector, which would represent the red stripe. So the first one, we're going to hold down the shift key and select on the second, or I'm sorry, the third. We're going to skip the second. Skip one, click, skip one, click, skip one, click, skip, and skip. We should end on the last one. And I'm going to move those vectors that I just selected to a layer, and I'm going to call that layer red stripes. And I'll even change the color to red. So you can see them there, those red stripes. And I'm going to turn that layer's visibility off. So for those of you that are new and everything, layers is a great way to separate complex designs into easier parts and stuff so you can work with them. So now I have my flag on one layer, and I have my stripes, my red stripes, on another layer, right? So they're separate. And so I'll turn that off and turn my flag on. Now, I want to take all of the remaining white stripe vectors and I want to group them together. Group them together. Okay? Cool beans. And now I'm going to put an emblem in there. So for the emblem, we're going to import another vector. And this vector is going to be from user's choice class. Will be this vector here. It's going to be a big one. Okay. All right. Now, before I go putting this on the flag, there are vectors in here that I want to turn off and vectors I want to turn on, because if you remember in the okay, we should be coming back. That all right, folks. I am sorry. We are buffering majorly tonight. And it's going to be a massive delay. I don't know where I'm coming in and where I'm going out. There is a major storm. So, all right, we're going to try this again. And Wade, thank you very much. While I was buffering, you sent over a super chat. Man, I appreciate that. Thank you for that. That helps a lot. All right. Okay, we're going to try. There's such a delay, there's a lag between what you guys are seeing and what I'm saying. So everything I'm saying right now, you're not going to see for about a minute or so. So I don't know where I'm, coming in or coming out. But what I just said was, Kurt, I'll try to get to the plate production. I've never used it in 8 years, but I'll see if I can explain it a little bit. It's just for making, it's almost like a label printer for mailing labels and everything. But I'll talk about that some at the end. It'll have to be at the end. Okay, so if I buffer. You're going to have to forgive me. It has just gotten so black outside, and it's daylight still. But this storm is bad, and I'm praying that power doesn't go out. It's really affecting the stream right now, so I apologize. We're going to try to get through this. I'll keep an eye on, and hopefully I don't buffer too much. Okay. Once again, I'm going to import a vector that's going to represent our emblem. And when I tried this a moment ago, it caused all the buffering, right? And someone's like, oh, I bet that badge ate up that RAM. If I import this again, and it does the same thing, we're going to change to a different vector. We'll use a different emblem. It doesn't matter. The emblem is not the topic. So, but let's try to start where we were, right? So I'm going to go ahead and import that vector in and see how bad it kicks my butt. Which it shouldn't be very bad. All right. I think we're doing all right. On this emblem, there are layers that I want to turn off and layers that I want to have on and all that stuff. And I'm going to group this together. Now, this is where I buffered the last time, trying to group the vector together. That's where I buffered the last time. But I want to go over to the group tool and group these vectors together and let the software do that. And then I'm going to get rid of this vector. Now notice what happened. When I grouped this, it grouped it onto that layer that was active, which was this layer here, and that layer popped up, right? I want to move this back to my layer 1 so I can turn off that layer again. But because I was playing with that layer and I had it active up here, it grouped to that active layer. So always make sure if you are working with individual layers that your layer that you're working with is active. You can see it up here and it's highlighted in bold. Okay, we should be doing all good. All right, so now I'm going to get this into position where I want it on the flag and get it sized up where I want it. And that'll be good. Now, when I have a complicated design like this where I've got vectors going through vectors and things like that, I need to do trimming. Not scissor trimming with the pair of scissors, but trimming using the trim tool, where I can clear the area of a selected boundary. I can clear inside that boundary to get rid of the vectors from inside of that selected vector, or clear outside of that boundary where it gets rid of everything that's outside of that selected vector. In this case, I don't have a boundary vector just yet to work with. I need to create that boundary. So I'm going to ungroup onto this layer. I'm going to ungroup onto the groups layer, which is the active layer here. And I'm going to select my outside vector. This is the vector that goes all the way around my perimeter, and I'm going to create an offset. The offset that gets created is going to be my trim boundary. Okay, so I'm going to offset outward, and for me, I like 1/8 of an inch. That's all I go. I don't go much. I don't go any more than that. Sometimes I go less, but for this, any emblem that I put on a flag, the trim boundary, which kind of creates almost like an island for the emblem to get carved on. I want it to be just an 1/8 inch larger than the design. So I'm going to offset outward by 1/8 of an inch. I want to select new, and I'm going to click offset, and I'm going to continue. Now I want to take my grouped stripes. And I'm hoping that when it buffers, that it still picks up where I left off, or I don't know if it's cutting off half the words that I'm saying. So, guys and girls, please bear with me. Or tell me, when I buffer, when I come back, am I saying something completely different than I was saying when I started buffering? I don't know. Let me know, because it's killing me. In my stream software that's going to the internet, it says excellent condition on the stream. YouTube is saying that it's not. So I don't know which one to believe. Still on track. Good. Okay. Earlier, the white stripes, the remaining white stripes, I grouped them together. And the purpose of that is I want the software to treat it like one object. So that way, when I select that grouped stripes, and then I hold down my shift key and select that boundary last, that's the key word, last, when we trim with the trim tool, it trims the first selected items from the boundary, which is the last selected item. And I can clear outside of that boundary or inside of the boundary. In this case, I want to get rid of all the stripes that are inside the star, right? I want them to be redrawn. And the trim tool, when it trims, gets rid of all that stuff inside that boundary, it redraws those vectors and closes them off. It doesn't create open vectors. So that's the important thing. So I want to clear inside of that boundary, and I want to refit the curves after clipping. Check that box, refit curves after clipping. So when I press clear, I have now, if I come in and delete my offset, my trim boundary, you will see that the stripes have been redrawn and trimmed around that area. And now I have this kind of 1/8 of an inch island around my emblem that it's going to get carved on. You know, cool beans. All right. Now, on my vectors, once I trim them, it ungrouped them because it redrew them basically and everything, and that's fine. My next step is when my bit comes in and cuts these stripes away, when it gets to the end here, I don't want it creating a little radius there and leaving a little skin of meat on the edge of my board. So all of the stripes on the right edge and the left edge are going to get extended beyond my board by a certain amount. You know, at least for me, I'm using a 1/4 inch Endmills, so I want the stripes to go at least 1/8 of an inch, so, or a little more than 1/8 of an inch, so that half that bit goes past the edge of my board. So what I want to do is I want to select the stripes. I'll select them on the right side here, because remember, they're trimmed, so there's some left side ones now too. But I want to select these, and I want to go into node editing. That's the second object. Now, when you're in node editing and everything, I'm going to select these outer nodes here. They'll turn red when I've got them selected, and I can use my mouse to drag them out. I can use the arrow keys on my keyboard. I can do whatever I want to move them out. Now I want to move them a specific distance. So I'm going to grab one. It'll grab them all because they're all selected currently. I want to put my mouse on one, and I'm going to drag that one straight out. And of course my mouse, I still haven't went to Staples and bought a new mouse with those super chats you guys gave me last week. But I want to drag this out, if it will let me. And I'm going to type in a distance. I stopped the movement. I'm still holding the left mouse button down. Now I'm going to type in a distance. In this case, I'm going to type in 0.15, and I'm going to hit enter. And that will move all of them out that 0.15 inches past the board. Got to move them all together. Now on the left side over here, I want to select these vectors. All right, bear with me. My mouse is, my mouse does not like the left mouse button anymore for some reason. And again, I'm going to do the same thing. I'm going to put my mouse over one of the selected nodes. I'm going to pull that node out, and then I'm going to type in a number, 0.15, and hit enter, and it's going to move it out, that distance. It will move those nodes in whatever direction I pull them by that distance. So if you're pulling the node at an angle and you tell it to move an inch, it's going to move an inch. It's going to shoot it up an inch. If you tell it to move left, right, and when I say tell it, I mean drag it. You drag your mouse and you stop moving. Once you move in the direction you want it to go, just stop moving, keep the left mouse button held down, and type in your value and hit enter, and it'll finish the movement to the distance you specify. Okay? Peter, I will, when we get into the 3D modeling, I might create a 3D on a wave, a wavy flag. I might take this file over to Aspire and do that, but I can't do that in VCarve Pro. I can't create a wavy flag in VCarve Pro. All right, now on this here, I've now prepped everything that I need for my stripes to carve out. So I can select all of my stripes here again. All the stripes, and I'm going to group them together. Now G for group is the keyboard shortcut to group them together. U for ungroup, right? So I can either use the group tool, move the mouse over there and do the click, or I can use the keyboard shortcuts, right? Cool. Now, the tool, the design is almost ready for me to create toolpaths on, but one of the main topics that someone was asked about, and it was a comment that was also in last week's class, is why didn't I clean up the nodes, those crazy wacky nodes, when you're in node editing mode, all of these nodes, right? Why didn't I clean those up? And my answer was, I showed a little bit about that last week in part 2. I showed a little bit about cleaning the nodes using the curve fit tool. But I was creating a model from them, and it really wasn't that important to me. But now I'm VCarving, and these nodes are points. These are runtime. These nodes add up to runtime, runtime and everything. So I'm definitely going to take a moment and clean them up, right? So we got this vector selected here, and I'm going to go into the curve fit tool. And on this, it is circular arcs for the most part. There's a couple of straight lines, but for the most part, it is circular arcs. So I'm going to leave it at that selection. My tolerance, 0.010 of an inch, is my kind of go-to default tolerance. I can tell it to keep sharp corners where there are some. And I want to replace the existing vectors. So when I click on preview, it'll try its best. It didn't really keep that sharp corner there because there really wasn't one there. But it's going to clean up those nodes so that when I am in node editing mode, I now have minimal nodes to deal with, right? Now, here, where I have these kind of fillets, if I wanted them to be sharp points and everything, then, if I don't think I can use, I think that's an arc. I can't use that as the fillet tool, but what I can do is I can delete this point here. Doesn't need to be there. And I can turn this from a straight line into an arc, which it already is, and I can pull that arc back out where it belongs. And then here, I can turn that into a line, and I'm going to delete this. I'm going to delete the span. If I want to go through and clean this up in node editing mode, I would delete this span, and I would use the extend tool. The extend tool will extend one line to its intersecting point. So if I click here and here, it will extend to where they would naturally intersect, right? To create that sharp point. And I could go through and do that all the way around in node editing. I don't want to spend a whole lot of time because we got a lot of stuff to cover in a very short period of time. But I could do that in let's delete this point. This is supposed to be a straight line. And here, this line, I can just delete the span. I don't need to do it, turn it into a line first or anything. I can just delete the span, use my extend tool to click here to there to create that corner, right? So my curve fit tool cleaned up the nodes, but it also changed them slightly. It changed the vector slightly. And I need to be mindful of that. If my tolerance is set too high or too low, I could really distort the image beyond what it should look like, right? And in this case, it wasn't so bad. It's just in these where there were no real sharp corners, it just needs, you know, to be redone. So this arc, get rid of this vector here. So delete that point. Delete that point. And when I do that, it takes the arc and kind of, you know, pulls it in. And that's because this arc should be going from point A to point B, but there's a point C right in the middle here, right? Don't need it. Delete it, right? So this arc here should go from point A to point B, and it should be arced, you know, one point to another. No, nothing in the middle needed, right? So same thing with this one that I was working on earlier. That one has that center point, and I could delete that point, and I could pull that single arc if my mouse lets me. I could pull that single arc back where it belongs, you know, and, you know, just clean up that way, right? So you guys hopefully get it. You get it, right? Hey, Big Daddy Fish, holy cow, Brooks Martin and Richard Brooks, thank you so much. My God, guys, thank you. That was a bit of a delay because I was looking at this screen, not this screen where those super chats popped up. Gentlemen, that's one way to start my engine. Thank you, guys. Thank you. I appreciate that. Wade, you too, everybody. Man, thanks for those super chats. Holy cow. We got Roger Brown jumping in there too. Thank you, man. Thank you. I appreciate that. Now, even on these straight lines, guys, let's go back to this corner real quick. Remember, delete this span, right? And then use the extend tool and come from here, click, click, right, to get that corner back. But even on this straight line, let me close this tool and go back to node editing, right? This straight line, point A to point B, we don't need these points in the middle, right? So this can stay, but we need to get rid of this point, and we need to get rid of this point. And this is not supposed to be an arc, it's supposed to be a line, right? So going from point A to point B. In here now, we've got this ball that's kind of coming around and then, you know, going into this. I'm going to actually leave that arc there. It doesn't need to be that dramatic. Am I going to leave that? No, I'm not going to leave that. Let's delete that. Let's delete that span. Let's do the extend tool. Extend from here to there. There we go. That's better. Yeah, it needs to be the point. Over here, same thing. And again, guys, there's 5 points all the way around, right? But you think you get it. Let's come in here. Delete the span. This arc, that arc doesn't need that point. Get it to snap back in. And use the extend tool from there to there. Right? So, clean up those vectors the best you can. And for the guy that commented, that watched, asking why I didn't clean up the vectors and stuff, it's because I didn't want to waste a whole lot of time. We got a lot of stuff to cover and all, but this is what you're doing. This is what we're doing. We're going through, and one more time, let's find a dirty vector, dirty, rotten scoundrel. Let's go into node editing. Here's one right here. The first thing is the curve fit tool. And again, we don't want to distort too much. We don't want to lose too much of our leaf and all, but this is going to be Bezier curves, not an arc. There's no arcs in here. It's a curve. Bezier curve. I don't want sharp corners, and I want to replace that vector. Now, it's going to replace it. It's going to minimize those points. Now, that was a good replacement. It did fine, right? So, if I wanted to, I could go in and select all of those, right? Let's turn off this circle, that circle. We'll turn off the F for right now, and the S. We'll turn it off for right now. We'll come back to the S. We'll turn off the star. So just this. All these nodes here. I don't need that one. That one's already cleaned up, so I can turn it off. And I will go in and just replace those vectors with new cleaned up ones, right? Quick and easy. I am not going to go beyond that. That 10 thousandths is fine for me. My wreath is still a wreath, right? Now I have less nodes to deal with on these objects and everything. When I go into node editing mode, things are, minimized. Now, to show, let me see. Let me find one with a little bit of, to show, let's go here. If I continued to click preview and OK, and go back again, preview and OK, I could go through and try to clean it up more and more and more to minimize, but at that point, when's enough is enough, and also I don't want to distort. So if I control what this looked like, Control Z, it went to kind of more of a stiff, look there, to this, to, that, right? So I might want it to be a little bit smoother up there. So that arc there, not bad for me, right? So you could continue with that curve fit tool, preview OK. But you might need to adjust your tolerance, and also don't distort the design. Don't distort the design to where it's not what it's supposed to look like anymore. Okie dokie, tokie dokie. All right. Now, in the scene of things, let's go through and select everything here. Everything. And then I want to, well, before I do that, I want to get rid of duplicates. I got some duplicates, I think, going on. Let's see. Let's find out. Right click, selection, select all duplicate vectors. There's none. So, wonderful. Happy-go-lucky me. None. But that just means I have vectors on top of vectors. So I'm going to get rid of that one, that one, that one, and that one. And on my S, that S is nasty looking. Let's go to the Curve Fit tool. Clean that up. I think all the rest of these are good. I think the O needs some work. That's the way it looks. All right. Let's see here. Down here, Texas. Texas looks good, except for the S. All right. So we're minimizing nodes, right? Now, I want to undo that S for a second. And you see that? See that straight across there? I don't want circular arcs on that one. I want Bezier curves. Preview. And unfortunately, can't do straight lines, right? So that's not an option. Looks like Bezier curves is what I got. Okay. All right. So sometimes it helps, sometimes it doesn't. I don't know, you know, but it definitely does help with the runtime. Don't get me wrong now. I'm talking out my butt. It definitely does help with the runtime. All right, let's go ahead and go through and select this entire thing. And what we're going to do is I'm going to, that looks crazy, doesn't it, with all that stuff? I'm going to go through and turn off what doesn't need to be messed with. So hold that shift key down. I'm going to go through and select some things. Let's close that tool. I'm going to go through and select some things that I don't want on. Let's do that. Here, let's do it smart. Let's do it smart. So that I'm going to group together. That's done. Done. All right. Everything else needs done. So we'll select that. Go into node editing. Oops. Turn off that group. Hold on. Hold on there, ladies and gentlemen. I'm still in node editing mode, still trying to select. Let's do that one more time so we can move on. Holy jeez, turn that group off. There we go. Node editing. And in here, when we come in, give it a chance. There we go. All of those nodes, except for the I'm going to turn off Did you just deselect the whole thing? You goofball. One more time, ladies and gentlemen. One more time. All right, I'm going to turn this off. I'm going to turn off the text here. And I'm just going to do it. I'm just going to do it. Node editing. Turn it on. I'm not, screw it. We'll see what it does. We'll clean up what it needs to clean up. Now, I'm a big advocate of redrawing text if it's a problem with a font and recurving it and all that good jazz, but let's go ahead and curve fit tool. Replace, we're going to just go Bezier corners, Bezier curves. It's kind of a combination of them all, man. I wish there was like a option where I could do more than one option, but let's see how bad it distorts it. All right. Hey, Doug Fushi, thank you, man. Evidently you are liking what I'm throwing out tonight. I don't know, but besides that mistake where we had some, I don't want to say the word because it might happen again. That's great. All right. So for the most part, we did okay. For the most part, we did okay. Just had a little bit of an overlap there. All right, let's get rid of, we're going to keep that arc. That's good. There's another one for some odd reason. Let's get rid of one of them. That we can move to the star layer. Move to star. Okay. All right. Okay, enough's enough. Now, when this carves, this is going to carve between the lines. Okay, it's going to carve between the lines and everything. And it's going to skip every other line. So what I'm going to do right now is I'm going to look at the V-carve of this. Now that it's all cleaned up, we can move on now. Holy cow, that was a whole thing. But we're ready for the tool pass for this complicated badge here. It's not that complicated. Number 1, stripes. Select the stripes. We are going to do not a pocket cut. Don't do a pocket cut. We're going to do a V-carve cut. So we get nice square corners. We don't get radius corners at all. Nice square corners. We are going to start at 0, the start point. We're going to flatten out. I like an 1/8 of an inch depth. You can go however deep you want. I'm using a 60-degree V-bit, and I am going to use a 1/4 inch end mill for the clearance tool. Now, raster cut or offset. I'm going to let it offset kind of round and around. You know, so that'll make it a little bit quicker versus back and forth and everything. So an offset is fine for these little pocket cuts. And this is going to be my stripes. All right, we're going to preview that tool path. So the end mill is going to come and carve all that out. And then my V-bit's going to come and give me some nice edges and sharp corners and everything. Okay, and there's my little island for the emblem to get carved on. Now the stars, I like the stars to carve to their full depth. So they're my next tool path. They're going to have no flat depth and no end mill. They're going to just use the 60-degree V-bit. I like that point and everything on the stars. So that's going to be my next tool path. And we'll calculate that. Let's preview that visible toolpath. Okay. Awesome. And thirdly, the emblem. Last but not least. Now, when I do the V-carve on this, if it looks odd and everything, I might have to go in and add extra vectors to make it look right, right? Because it's going to carve between 2 lines, skip 2 lines, carve between 2 lines, skip 2 lines. So I don't know what you know, what the end result's going to look like. If I don't like the way it looks, then I'm going to need to add in some additional vectors to make it look like I want it to look, right? So we're going to go VCarve toolpath. On this one, I will set a flat depth because there's a big old wide gap. I don't know how deep it's going to carve and all, so I am going to set a flat depth, and a 1/4 inch bit isn't going to cut it. I'll use an 1/8 inch to help out with the flat areas. So your bit selection, your end mill, your clearance tool, your end mill is going to be based on how big of an area it fits, you know, 1/8 inch, 1/16 inch, 1/4 inch, 1/2 inch, whatever. And because it's a box here, that box there means that I can add multiple tools in there, however many tools I want for that flat area clearance tool. I could use a 1/2 inch, 1/4 inch, 1/8 inch, and it's going to carve those in that order until it's done, right? But in this case, I'm using one bit. My 60-degree V-bit does all the nice edge work. 1/8 inch end mill. If there's any flat work to be done where it can fit, it'll fit there. And this will be my emblem. And man, everything that I'm doing right now, I got to set the flat depth. 0.125. Everything that I'm doing here is the same steps, rinse and repeat for every flat flag with an emblem in it. It's literally the same steps. And I got other videos that are specifically focused on this. Now, there's some overlaps. Of course there are. Those overlaps have been created from that curve fit tool. So there's a little bit of good and evil in everything, right? So you got to take the good with the bad. The good was we cleaned up all those nodes. It's going to make our carve faster. The bad is it's distorted our design a little bit and it's caused some lines to be overlapped. So, and it might also be zero length spans created too. So let's search it and see what the problem is. All right, so we have 9 zero length spans that were created, 3 overlaps, 12 intersections. So we're gonna fix the zero length spans. There's a button for it, right? Click that button. Done. Zero length spans are taken care of. Now we have let's search it again. We have 3 overlaps, 12 intersections, which isn't that bad, right? So that's good. And they're going to be here. So there is a small piece of trash right there that's going to get deleted. But there's a couple of overlaps right here on this leaf there. There is an overlap here to deal with on the right side. And that looks to be it. So let's deal with this first. Remember now, this is all grouped together here, so I'm going to right click and I'm going to ungroup it on the layer that's active so it stays on its layer. And I'm going to select this piece of trash and hit delete to get rid of that. Here on this and this, I'm going to choose my battle, which vector I'm going to deal with. In this case, I'll deal with this one, and I'm just going to turn this off, smoothing off, so that it doesn't affect this line. And I'm going to twist this around to create that arch there, right? To get rid of that overlap. Okay? Now, on the other side, we had this overlap here. There's kind of a lot of stuff going on. There's a bit of a figure 8 kind of deal going on and all that stuff. And it's all one continuous vector. Okay? So, first things first, try to pull this over here. Pull this, not the whole thing like that, grab just one. Pull that over there. And there's my separation, right? So I can move this over a little bit. So there's the separation. And up here, this line loops around, it crosses around. So I am actually going to eliminate this. I'm going to delete this span. I'm going to delete this span, delete this span, and eliminate that problem altogether. Now, I'm going to verify that it's a closed vector. I'm going to go to my join tool and make sure it is a closed vector. And so we eliminated that little look there. I am going to take, in node editing, I'm just going to take these two nodes and I'm going to back them down a little bit using the down arrow and all. I'm going to pull this back a little. There we go. All right, so that's that. Now, if I come in here and select that vector again, and I'll do the vector validator, right? Vector validator. Search VCarve, search selected. Fingers crossed that we resolved all issues. There might be one or two. Yeah, we did. All right, cool. Now we can go back to what we were doing, calculating our toolpath. Now, again, I don't know how this star is going to carve right now. I don't know if it's missing a vector or not. I do know that there is one open vector that's being ignored, and there are 283 that are still going. Now, I could click OK and let it finish calculating, or I could cancel this and find that open vector. I'm going to take the second, since we're already this far, and I'm going to find the open vector. So let's come over here and right click and select all open vectors. Now, the open vector is the wreath. I can't have that being ignored. That's an important part of the puzzle, right? So I need to go over to the join tool, and I need to take that open vector and click join to close it. All right, cool. Now we can do it one more time. Calculate. All right. And guys, you don't know how great that super chat was. All of you. Wade, Big Daddy Fish, Brooks, Richard Brooks, Brooks Martin, Roger Brown, Doug Fushi, thank you so much. Now, it looks good. It looks good. It looks like it's carving the things I want it to carve. Don't know yet. Let's take a look. Preview the visible toolpath. And let's see if it's carving what I want to carve and not carving what I don't want to carve, right? Now, I'm going to paint the sign, right? So let's paint the emblem black. I'm going to use the color toolpath here. Let's paint the emblem black. Let's go, we'll go black for the color on this one and this one to fill it in. Okay. Looks good. Now, if I wanted to reverse this, if I wanted county raised, deputy raised, and I wanted the these areas carved down and the text raised up, then I would have to add an additional vector to do that reverse, right? So it reverses everything. And right now it's not reversed, right? It's this way. So I added color to it just so I could visually see it better, you know, just kind of detail and stuff. Now, let's take a second and I'm going to add an additional vector around it so you can see the reverse effect, right? So on here, I'm going to take my outside vector and I'm going to offset. Now I went 1/8 of an inch on my stripes, right? If I wanted to, you know, if I wanted my offset to be quite wide, I would redo the stripes again. I'd back up and redo the stripes. But I'm just going to go 1/16 of an inch. Offset outward 1/16. Okay. Now I'm going to come in and recalculate. I'll just calculate a new toolpath. New toolpath. Everything stays the same. I'll call this my emblem 2. Because it's option 2, right? Okay. Now, let me reset the preview. now you can see what all is going to be carved and what all is going to be raised on this, right? So let's take a look at it. So let's look at our stripes, our star, and this. Let's preview the visible tool pass. So we got our stripes getting carved. We've got our stars. And then we have our emblem. Okay, now let's add some color to our emblem to see what this one looks like. Okay, and so in my opinion, the other way looks better. You know, or it could be a combination of, you know, I like some of it, but I don't like others. I might want to add more vectors and try to get things to raise up and go down and blah, 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 what have you. But it's, for me, it's one way or the other. I'm not going to spend too much time on it, and I do not like the way this looks. So I'm going to undo the last, and I'm going to go back to my original, which I prefer this. Okay, but I could go in and I could manipulate those vectors more. I could add more vectors here. If I want something to be raised up instead of carved down, I just have to add another vector, another boundary somewhere. But I don't want that. I don't want to deal with that. I want this to be carved exactly like it is. So on my flag here, in a sense, basically, my stripes would be white. My stars, they would be white also. All right, now I'm going to do something for visual purposes only. Ladies and gentlemen, it's for visual purposes only. All right. But when I look at this in the preview, if I change the color of my board to a solid color, let's say red, right? My entire board is red at this point, and I want to change the emblem from black to blue. Let's go blue with the emblem. Now, you're gonna see what I'm talking about here in just a minute. Let me change this really quickly to blue. Let's turn off all this. Okay, now, just as an example, the union here would not be red, right? It would be blue with the white stripes. So I have a rectangle vector here. I'm going to take this vector and I'm going to bring it out just a little bit this way, and I'm going to bring it up just a little bit this way. God help me. Bring it up just a little bit this way. And I'm going to create for visual purposes only. This rectangle would not be used in the actual tool pass. I'm going to do a pocket cut with a cut depth of 0.001, 1/1000th of an inch. And I'm going to use 1/8 inch Endmills fine because it's just for visual purposes only. And I'm going to call this my union area. Union. And I'm going to click calculate. I'm going to preview that visible tool path. And I went so small because I don't want to mill my stars away and stuff, you know, what they actually look like and everything. But on that, when I mill that away, I want to change that color to blue on there. So when I'm looking at this preview and the emblem, I'm going to go to white. I got to go white. The colors just aren't popping. Let's go white. Come on, give me a color that's gonna look good. Give me a second here. Let's go. Nope, that looks like crap. Nope. None of it looks good in the preview. Yeah, none of it looks good in the preview. So we'll stick with black just for now, just for preview purposes. But I did that 1/1000th of an inch cut so that it milled just a little bit of that surface off, just so I could add a color in there for my preview window. So I could just add a color, so when I'm saving this preview image, I can save it and you know, send it to someone and say, hey, here's what your project's going to look like. You want to make any changes, blah, blah, blah. Right? Right. Now, if I wanted to, I could even take my outside outline area right here, and I could have left that vector in there and made a small little pocket cut again on that and changed the color of that overall area there. I could have given it the color white or something so it stands out better in the preview, right? So anyway, that's that. All right, let's move on. Okay, so we have a file that we're going to save that we're going to use. Probably we'll make a wave out of it or something or whatever, but we're going to call this our sample VCarve flag, and I want to put it in the user choice class folder, and I'll do with badge just so I know what it is, and hit save. Let's save that. All right, so now I've got my toolpaths here. I want to optimize the toolpaths. I'm not going to save the toolpaths, but I'm going to show you how to save them. I want all of my bits to go together. So 1/4 inch bit first. 1/8 inch bit is going to be next in line. 1/8 inch bit next in line. And then all the V bits, even my union's an 1/8 inch bit, that goes next in line. And all my V bits. So it carves all the 1/4 inch stuff first, the 1/8 inch stuff next, and then the V bit stuff last. So when I save this, I'm in 11.5, and I'm in 11.5, and so I'm going to select all of them, and I'm going to have the option at the top, visible toolpaths to multiple files. Visible means checked. Checked. I can visibly see the red, blue, and white lines over here. Visible. Visible toolpaths to multiple files. If they use a different bit, save them as separate files. Group where possible. If they're in order and they use the same bit, group them together as one file. That's what that means. If I have VBit, Endmill, VBit, the Endmill's in the middle of the two VBits, it's not going to group the VBits together because there's a tool separating them. But if I move that Endmill up first and the two VBits together, then it'll save the file for the Endmill and it'll save the file for the two VBits together as one file. So I've got my 1/4 inch Endmill first, my 1/8 inch Endmills in order together here, and then my VBit. So by choosing that selection, I'm going to have 3 toolpaths that are created when I save this. So I'm going to give it a generic name. I'm going to call this my VCarve flag with badge. And then when I hit save, it's going to save those 3 toolpaths. And let's pull the window out here. File number 1, my 1/4 inch Endmill. Files 2 through 4, 2, 3, and 4 in that list. My second, that's my 1/8 inch Endmill, and 5, 6, 7, and 8, that's my V bit. Now, if I want the bit information in there, I need to add that information to the toolpath names. Right-click and, rename them and add the tool information in there so that it'll add that to the name if you want. Right? All right. So, Doug, thank you very much, my man. Doug, this is Doug's first super chat. Thank you so much. Doug the Doll. Doug the Doll. Is that Doug Fushi? Is that your first time doing a super chat, Roger? But yeah, thank you guys. Man, thank you so much. You have no idea. All right. Now, we have this flag and everything here. So this is the V-carve of a complicated. So the customer that posted the post saying it would be nice to learn how to carve a complex V-carve like a flag with an emblem, right? Here we go. All right. Not a whole lot. We spent some time on the nodes, right? Cleaning up the vectors, the nodes, and that's going to make our tool path run, faster. But we imported a flag file. We imported an emblem, and we removed the red stripes, put them under the layer because they don't get carved, right? So when we look at this from the side here, only the white stripes get carved, right? So, and I'll go back to the material color. Let's go back to Canadian maple just to get it back here. But only the white stripes get carved, right? And we pulled those stripes out past the line so we get these nice clean edges. That's why we did that 0.15 past the edge, so the bit could come past that edge and everything and give us that nice clean edge. All right, now moving on. All right, the next topic was talking about, the next topic was talking about bits and speeds and feeds, and I want to discuss that right now because it's more of a discussion than a display. So there are generally two rules of thumb that you need to be aware of when you're carving. On your chip load and everything, most mid-size units, not your commercial, not you guys and girls that have commercial units and things like that, but most mid-size and hobby units, the Shipokos, X-Carves, digital wood carvers, and things, your RPMs, how fast that bit is spinning, the speed of the feeds and speeds, the speed is the rotation of that bit. So when you hear the term speeds and feeds, the speed side of that is the rotation of the bit, the RPMs. Now, no one with a mid-size unit should be running any bit over 18,000 RPMs. There's no need for it. There's no need to be at 20, 22, 24,000 or anything. If you have a router on your dial and you don't have a spindle that the software controls, turn that router, if it's the, if it's a palm router or whatever, generally between it's 1 through 6 on the dial, generally between the 4 and the 5 is around 18,000 RPMs. That's where you need to be. You don't need to be at 6 for every tool that you do because you're running 24,000 for all those tools. Turn it down. 18,000 RPMs is a good, if you look at any router bit company and you look at their specs for their tools, they are basing their specs generally off an 18,000 RPM setting. And in your case, we're going to be 18,000 or less. Now, rule of thumb. Larger diameter, slower the speed, right? So let's say I'm working with 1.25 inch surfacing bit, okay? For me, anything kind of over 1 inch, I start slowing things down. 1.25 inch surfacing bit, we're going to be probably running around 16,000, 14 to 16,000 RPMs. I generally run mine at 16,000 very well. But we're going to be around 14 to 16,000. Now, you get up into your 2-inch diameter bits, and for any of you mid-size and hobby units out there, your surfacing bit should not be any bigger than 2 inches. No. Your commercial units, sure, you can go as big as you need. But hobby units and all, just not enough. There's not enough mass or construction to turn the big bit anything over 2 inches. Just don't do it. It's dangerous. It's crazy. Anyway, Larger bit, let's say a 2-inch diameter, we're going to be probably around, 11 to 12,000 RPMs on that guy and girl, on that item, and stuff. So just keep that in mind. Turn your dials between 4 and 5 and kind of, that's your starting point. Now, we talked about going larger. The larger the bit, the slower the speed. Reverse that. Also, the smaller the bit, you need to start kind of slowing things down as well too. Because as your bit gets smaller and those gullets on those cutters, those flutes and everything, they get smaller, they can't produce more of a chip. They can't produce too much of a chip. If they're spinning too fast, they can't really cut, right? So that bit needs to slow down. I've run 1/8-inch Endmills, at 12,000 RPMs at times and stuff, and 11 and 12,000 RPMs. I'm not saying 18's good, but you can fine tune it, fine tune your cuts, and see where you need to be. Now, Ron, thank you very much. I appreciate the super chat, brother. Man, you guys are helping me out so much. You have no idea. I'm about to cry. All right, thanks, Ron. Rule of thumb. Here we go. If you've ever been carving and you've got just this whining bit, it's squealing and screaming at you like a pack of hungry puppies at feeding time, right? Just it's just whining at you. All right? What that is the bit, the feed rate. Now, okay, we talked about speed. Speed is the rotation of the bit. Feed is the movement of the bit through the material. Feed. Plunge rate is how fast the bit is plunging into that material for its cut. Feed is how fast it's moving. Now, if you got that high pitch whine and wheel and everything, with your bit and all, what that means is your bit's feed rate is too slow. Your bit is moving too slow and the bit is spinning too fast. Now, that bit literally is spinning so fast and moving slow that it's actually rubbing. It's not taking any cut. Each flute is coming and it's rubbing the wood. What you can equate it to, for any of you country guys and girls out there, have you ever seen anyone use a box turkey call? Where that lid, that wood is rubbing on top of the box. And I can't make a turkey call, but that whining, that's exactly what's happening. That bit is just rubbing. As it's turning so fast, it's just rubbing, rubbing, rubbing. It's not taking a chip because it's already taken that material, but it isn't moving fast enough to take more material, so it's whining, it's squealing. So on that high pitch, you need to go faster. I'm telling you, go faster. And you need to turn your RPMs down. That needs to spin slower. Your speed needs to be slower, and you need to be moving faster. You find that happy medium. If you turn yourself down to 18,000 RPMs, if you were traveling, let's say, 60 inches a minute, and you got a high pitch wound, go up 70, 75, go a little faster and everything. And in some controller programs, you can control the speed on the fly. In the controller program that we use called Planet CNC, I can increase the speed, the feed rate, not the speed. I can do the speed too, because I have a water-cooled spindle. If you have a router, you can't control speed with the software. But the feed rate, I can control it. I can go faster or slower by 10% increments. 100% of what the G code is, and then I can go 110, 120, 130, 140, or I can go 90, 80, 70, 60 of that G code. I can speed up or slow down. And I can speed up and I can turn down my spindle's RPMs at the same time until I get that nice combination. Now, okay, you're going to want to be on, if you're on any side of the spectrum, that's the side you want to be on where the bit is whining, okay? Because you just got to go faster and turn that speed down, that RPM, go spin that bit a little slower. Not too slow, but slow enough that it can take some meat, but it's moving fast enough that it's taking good chips. We want chips flying out, not dust. And dust, with that high whine, if you looked at your table, you probably got a more collection of a fine dust than a chip pile, going on there. Now, On the other side, thanks for the turkey call, Richard Brooks. On the other side of the spectrum, if you are breaking bits, you're snapping bits, or you're actually pushing your material around off the clamps, you know, you got it clamped down, but you're still pushing it off the clamps, or you're breaking bits, or you're getting vibration and chatter and things like that. You can visibly see it, you can visibly hear it and everything. That's the other side of the spectrum. You're going too fast on your feed rate, and your bit is spinning too slow. Slow down the feed rate, increase the speed, the RPMs, until again you get that good combination where you get a good, nice, good sounding clean cut. You do not want to be on this side of the spectrum, because if you're going too fast and your bit spinning too slow, you're breaking bits or you're damaging something. Okay? You're breaking bits, you're pushing your board off your clamps, you're causing torque on, if you don't have a strong, rigid, you know, construction system on your machine is flexing and stuff, and you know, it's not the good side of things, right? So if that's the case where you're like, man, why do I keep breaking bits? Slow down. Go faster on the RPM, slow down on the feed rate. That's the other side of the spectrum. There's only two sides of the spectrum. Right in the middle is your sweet spot, right? Finding that sweet spot for the material that you're carving in the bit, that is the most challenging part of the carve. And once we fine tune, hey, I can run my 1/8 inch bit in pine at, I could go 95 inches a minute, 18,000 RPMs, and I'm looking good, or whatever the case may be. Whatever those numbers are, I'm making notes all the time at the machine, and I'm adjusting my tool database accordingly based on that. And when you get fine-tuned in, you're making beautiful chips. That bit is just cutting through. The machine's not struggling. There's no torque on the router or the bit itself. You're not breaking bits every freaking time you try to carve something. You're getting it. You're not like going deaf because it's loud and, you know, pitchy and everything, because again, too slow, spinning too fast, right? If you're loud and pitchy, speed up the feed rate, turn down the RPMs. So give me a thumbs up if that explanation helped you any, or kind of give you some food for thought for when you go out and do your next carve. All right. That's the discussion on speeds and feeds, guys. That's it. We're going to move on now. So, you 18,000 RPMs is good for everybody. That's your starting point. Slow down as that bit gets bigger. Slow down as that bit gets smaller. You know, your feed rates and all. Listen. It's audible. Listen to your machine when it's carving. Listen to that bit and everything, and adjust accordingly. That's it. All right, you're welcome, Sylvia. Okay, now, the next thing. Let's just one more final thing to talk about bits and all. I'm going to import a couple of vectors. I'm going to import a vector. I wonder, tum, 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 tum. Let's import one vector. All right, let's import another. All right, let's not do that. Let's move one out of the way first, because they're all going to land right there, because I'm just that kind of guy. All right, import the next one. Let's move that one over here. Import the next one. Over here. All right, let's talk about really quickly to finish up the V carving side of things. We're going to get into, stick with me guys. This might be, we're going to try, we might have to break this up into multiple classes, but we're going to try to get through one more topic tonight, and then we might do a part 2. But let's finish up V carving, okay? And let's talk about understanding V-carve toolpath for a moment. You have a start depth and you have a flat depth, okay? Now, for the most part, okay, for the most part, and this key tip is going to play a big role when it comes to V-carve inlays. So pay attention to this part because you're going to hear it again when we talk about V-carve inlays. But when we are talking Z0, okay, according to Vectric, as far as Vectric's concerned, Z0 is the top of our material or our machine bed, our wasteboard or the top of the material, whichever you got it set up for. But that is Z0. Now let's, for ease of understanding, let's talk about the top of the material for right now. So your Z0 position is the top of your material. Your start depth is a depth. Let's say I go into node editing. Bear with me a second. Let me insert a point here. And let me insert another point there. Let me bring this down. And this here. Okay. Now, your start depth is going to be, and to make this a little bit more realistic, let's make that a V-bit. It's a crooked V-bit. Hold on a second. Straight down. That's good. Okay. So, Z0, top of material. Your start depth is where you want the bit to come down to start. Now, Vectric assumes, let's say your start depth is 1/8 of an inch. Let's put a line here that represents 1/8 of an inch, and that's the start depth. Now, Vectric assumes that the area here, this area here, this material here, is gone. And in this case, we have a blank board, it's not gone, right? So when we set a start depth, Vectric's assumption is that material's gone. It's been milled away, and we're starting down in this pocket. In the case of, I have a blank board here, and I set a start depth because I want my bit to carve deeper or whatever, that material is not gone. So especially when it comes to V-carve inlays, and we'll talk about that when we get to the inlay part, but your start depth, be mindful that you're pushing that bit down, you're forcing that bit to plunge, whoops, to plunge straight to that start depth, and then it's going to go to the cut depth from there. It's plunging, don't stop, don't pass go, don't collect $200. It's plunging past that start depth. That's where it's starting, and it's going down to its next cut depth, right? That's just the start point. So if your start point is too big, then your bit is plunging into a massive amount of wood that's still there. Be mindful of that. Now, where this is generally used when it's not zero is if there is a pocket that's been cleared out. So if I have already cleared out a pocket and I need to do a V-carve down in that pocket area, I need to do a V-carve down that pocket area, I don't need it to start at 0, the top of the board. Z0 is the top of my material, right? I need it to start down at this pocket. So my start depth would be 1/4 of an inch or whatever it is, right? Whatever that depth is. and I'm carving from there to my flat, if I have a flat depth, a limit, I'm carving to that full flat depth that's limiting that cut. It's cutting it off there. And generally the start depth is would be a large number if I'm carving, if I need to get down to a certain area. If I'm working with a flat board, my start depth is just, in the case of a V-carve, I might be using it just to get a little bit more definition out of my cut. It's not proper, but it works. Proper to get more definition and depth out of your cut, use a narrower V-bit. We're going to talk about that in a second. Just want you to know what start depth is in a V-carve toolpath and what flat depth is. Now, you're going to get a better explanation of it and a better understanding. You'll probably understand a little bit better when we actually do the V-carve inlay side of things. But that's the gist of it. 0 top of material. Start depth, we're forcing the bit down to a certain depth. Vectric thinks that material from between 0 and start depth is milled away, right? But it's not, so you just got to remember, you're plunging your bit. It's a straight plunge. It plunges all the way to where it's got to cut to. Not the start depth. It doesn't start there. It starts where it's got to cut to, past that start depth. So we're forcing that bit down in, so just keep that in mind. This is a generic kind of explanation for now, just to kind of let you know what start depth is and all. Flat depth is a truncation of the V. Now let's come over to this graphic to better understand flat depth. So in the case of this particular cut here, my V-bit, cutting down to its full depth here, is doing a V-carve with no flat depth. So the software is looking at the distance between two lines, in this case 3/4 of an inch. It's looking at the angle of the V-bit that I'm using, and it automatically calculates how deep the cut needs to be for those two lines to meet at a V. So if I'm using a 120 degree V-bit, it's going to be a shallower cut. 60 is going to be a little deeper. 90 is going to be a little bit deeper. 60 is going to be deeper, and 22 is going to be even deeper. We'll see that in just a minute in the next graphic. But this is the example of a full V cut. It's cutting to that full V. When we set a flat depth, and this is where I see a lot of people confused, they think a flat depth is a cut depth. In your tool pass, your profile cuts, your pocket cut tool pass, your drilling operations, you have what's called a cut depth. You're saying, hey, cut from here down to here, cut to this depth. That's a cut depth. The V-carve toolpath automatically calculates that cut depth based on space between the two lines and the angle of the V-bit. Closer the lines, shallower the cut, further the lines, deeper the cut. It automatically calculates that. The flat depth is a limit. We're cutting it off. So if I set a flat depth of 0.1875, when that bit comes and cuts, when it gets to that depth, it's going to flatten it off. Now, not every single part of the V-carve toolpath will reach that depth. If a cut would have normally exceeded the 3/16 of an inch, 0.1875, if the cut would have normally exceeded that cut, that particular part of the cut, will get limited to that 0.1875. Everything else in that V-carve that would not reach the 0.1875 will get cut to its normal depth. I see a lot of people call me up and say, hey, no matter what I do, my bit's not carving any deeper. It's staying at one depth. I've got it. I told it to cut a 1/2 inch deep, but it's only carving an 1/8, whatever. And when I look at ask them what type of toolpath they're carving a V-carve. And I'm like, okay, where are you telling it to carve a 1/2 inch? And they're putting the 1/2 inch in the flat depth box, thinking that it's supposed to go down to that depth. That's not the case. It's a limit, saying any part of that design that's going to exceed 0.1875, limit that part of the cut to 0.1875 and flatten it off. Truncate the V, flatten it off. Anything else in the design that would not exceed or come close to the 0.1875, carve it to its natural depth based on the angle of the V-bit and how deep it needs to cut for those lines to meet at a V. So a flat depth is not a cut depth, it is a limit. Need you guys to understand that, guys and girls to understand that. And if you do, good. We can move on. Now, understand something. If I have the same space between my lines, okay? If I have the same space between my lines, depending on the size of the V-bit that I'm using, that will determine the depth of that cut that I'm talking about. How deep it takes for those two lines to meet at a V. In this case, if I'm using a 120 degree V-bit, or a 90 degree V-bit, or what have you, it's going to carve to a certain depth based on how deep it needs to carve for those two lines to meet at a V. If I'm using a 90 degree or 60 degree, in this case, 60 degree V-bit, it's going to carve deeper. So in this first example, same space between the lines, same space, the space between the lines has not changed, but the depth, 0.115 to 0.1914, has changed because the V-bit's angle has narrowed. If I go from a 60 to a 30 degree V-bit, 15 degree side angle, 30 degree full angle, I'm going to be carving on that same space between the two lines. I'm just going to be carving down to 0.2687. And if I'm using a 22 degree V-bit, I'm going to be carving down to 0.4141 because that's how much it takes for those two lines to meet at a V. So when that bit comes down and it's carving, when the bit's edge intersects with those two lines on that center point and everything, when it intersects on that center point of those lines, that's how deep it's going to carve. Okay? Understand that. So, this is a sample of a V-carve toolpath depths changed based on the angle of the V-bit. The narrower the bit, more detail. So the smaller the bit, the finer the V-bit, the finer the detail, the better the detail, the finer the detail, however you want to say it, the finer the detail. The wider the bit, the less detail. So if you have a V-carve toolpath that requires, lots of detail and stuff and has lots of fine little detail, you probably want to be using a narrower V-bit to carve that. Just understand that it's going to carve deeper, so you might have to set that limit, the flat depth. So it all plays a role, right? And so wider the bit, shallower the cut. As it gets narrower, it starts getting deeper, and that's a V-carve. That bit gets deeper, so it takes more depth for that lines to meet at a V. Okay? Cool. If you understand that, we're going to move over to profile cuts with a V-bit. Okay, profile cuts with a V-bit. Now, in the case of a profile cut with a V-bit, we're setting a cut depth now, right? Profile, pocket, whatever. Let's do a profile cut that makes more sense. The profile cut, the cut depth, we're starting at 0 and we're cutting down, in this case, 1/4 of an inch. So all of the cuts are going to be 1/4 of an inch deep. Now, what changes with the profile based on the angle of the V-bit is how wide our groove is. The narrower the bit, the narrower the groove. As our bit, all of them are going to cut down to that 1/4 of an inch, but as the bit gets wider, our groove that bit is cutting on that profile cut is getting wider. As our bits get wider, the groove gets wider. They're all cutting down to our cut depth, 1/4 of an inch. But our line now is going to be either a wide line or a narrow line. And let's, in realisticness, let's take a line here for an example. And let's just put a line right there. And on the profile cut, I will select a 22-degree V-bit to cut on the line. We'll calculate that toolpath. And let's reset this back to a blank board. Let's turn this upright, slightly like that, and preview that visible toolpath. So with that 22-degree V-bit, we have a nice narrow line. Now, if I take that line and I'm going to create 3 more of them, and let's go 3/8 inch. Let's go 5/8 inch apart. Oh, actually it needs to be on this one, 0.625. Okay. So let's go, hold on, let's go. Okay. So on my next line, if I do that same profile cut, but I choose the 60-degree V-bit, preview that. Okay, that line will be wider. Let's go same third line. Same profile toolpath. What were my other 2 toolpaths? Profile. Let me come back here. Let me change that depth a little bit to 0.25. I don't know why I had 0.75 on there. Calculate, that was that one. We have that one, 0.25. Calculate. Okay, good. All right, number 3. Stand by 1 second. 0.25. Calculate. My left mouse button just doesn't like me today. All right, line number 3 is going to be the 90-degree V-bit. So we're going to go with the 90-degree. And line 4, we'll just go 120. I think you guys and girls get it. I think I'm beating a dead horse right now, but we'll calculate that and preview. All right, all 3 of these, and that one almost ran into, that one it did run into, but all 4 of these are using the same cut depth but different angle bits. Our 22-degree V-bit, 60, so 60 is just slightly wider, right? 90, and then our 120. So the only thing that changed based on the angle of the V-bit was how wide our groove was. So when we're using a V-bit for our profile cut, the angle of the bit is going to determine the width of the line, okay? Which is opposite of a V-carve with a V-bit, because the space between the lines and the angle of the V-bit determines the depth of the cut, right? Because it automatically calculates that cut depth. All right. Hey. Thanks, guys, for all the thumbs up. All right, so hopefully that little explanation of profiles and flat depths, full V-carves, and how the angle of a bit is, changes the depth of cut on a V-carve, hopefully that explanation helped some or gave you something, again, food for thought, right? Something to think about. All right, let's go ahead and let's get rid of these lines. And let's get rid of these vectors. I don't want them when I bring this flag into the Aspire or anything. I don't want that to be affected. And I want to take this, and this, and delete the visible. And then I want to take this, and delete the visible. All right, cool beans. Okay, so we're going to hit save on this project, and we're going to close out of it. Now, very quickly, this is the last thing we're going to talk about tonight, and then let's get a vote. Let's get a vote. Either this coming Tuesday or the following Tuesday with normal class time, like we did with the last week's class. Part 2 is going to be doing the talking about photo V-carving, V-carve inlaying. We're going to do a little bit more 3D. I'm going to talk a little bit about 3D right now, but we'll kind of continue 3D in the next class. And then we're going to talk about V-carve inlays. Very good class. Very good information. You're going to want to watch that one. And then we're going to talk about photo V-carving and everything. Now, because someone did, before I move on to 3D, because someone did ask if I could explain a little bit about plate production, I just want to show that tool. Okay, so in plate production, I need to have a vector selected, or it could be multiple vectors and everything for the tool to open up. Now, basically, this think of like the Avery labels that you buy at the office supply. There's different size labels, right? There's different, it comes on an 8x11 sheet, goes in your printer, but there's big labels, there's little labels, there's return labels, there's all kinds of different labels, right? That's what this is. So we have our sheet size, and you would set up your sheet size. Now, by default, our sheet size is 24 by 24 in this case, right? It picked up what the size of my sheet is. The plate size is going to be based on the vector I created, right? That guy. That box, I just drew a random box, but it is 7.5 by 2.25. So it's automatically selecting that. Now, on my sheet, these individual plates that are going to be laid out on the sheet, is there a margin, left and top margin, equal margins, not equal margins and all, around these plates, from the sheet, edges, top and bottom. Okay? If it's equal margins, you only have to set one and it'll make the others match. Spacing X and Y from one plate to the next. And you got to think about kind of almost like the copy array tool, that spacing, we're creating the array like we did with the stars earlier and stuff. But it's asking, what is the spacing of your plates? And in this case, let's say that my plates are spaced 1 inch apart on X and 1 inch apart on Y, just as an example. Now, this is going to say based on the size of my plates, the size of my material, my margin settings, number of plates I have 2 plates along the x-axis, 7 plates along the y. Okay? It auto-calculated that. All right? Now, what do I want to engrave? And it's a one, you can't do multiple engravings on different plates. In this scenario with the plate production, you're doing one engraving. So let's say that I was, this is plate production. 2023. Now, my separator and everything, I can use like comma delimited, type things, separator. If I had, multiple things, I can do commas, tabs, semicolon, space. I can import what's going to be the data to be engraved. I can import that from a file. The file type is going to be a text document or a cs.csv, Excel document, comma, delimited, CSV file. And it's going to, so if I did have multiple addresses, I guess I could do that. I could comma delimitate them, right? And put them in. Or I could just type in, you know, what it's going to be. Okay. When I calculate this and everything, number of plates, sorry, I need 14. Bear with me a second. 14. Maybe it's not going to let me do it without importing a file. Da, 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 da. I bet you it's going to... Number of plates. Come on. Why won't... Hold on a second. For some reason, it's not letting me type a number in now. Okay. First row is column name. Number of plates. So when that's checked, can't change that. All right. One plate per... All right. So number of plates. Let's go over to here. And let's click close for a minute. Just for a minute. Use the handy dandy get help on this tool, right? And let's come down to plate production and let's see what it says about our plate production dialog. So the number of plates that will fit, toolpath options, import data. So the right hand side of the plate production form is used to select the data that will be merged into the template, and how that data will be interpreted to create each plate or badge. You import the required text data file using, so it's required. So we do have to import something. It has to be comma delimited and what have you. So let's create a text document. All right. I am going to, I wonder, let me see here. Let me test my theory. I'm going to create a comma. Copy that. Control V. Control V, Control V, Control V, Control V, Control V, Control V. Okay. File. Save as plate sample. And we'll throw that in user choice and hit save. Let's import the file. And comma delimited it, pick that up. Let's calculate that. All right. Now, it automatically calculated 16. Okay. Close. Now, I have these plates, but I don't see any text. So, let's see what it goes on and continues to say really quickly, and then we got to move on. Plate production. All right, so import the file, the separator, the first row column name. It is very common for the first row of data in a file to simply show what each of the file fields are, so we don't need that. That's not the case in this case. All the variables specify the template and text. So all of the variables specified on the template text with double exclamation marks on either side are automatically listed on the form. This would look like that if there's variables. First name, street, company, address. Again, just like printing damn labels. That's exactly what we're doing. Excuse my language, but that's exactly what we're doing. Variable assignment, calculate. Click calculate to create the badge and associated toolpaths. If the toolpaths have previously been calculated, if toolpaths have previously been calculated, close. All right, let's go back to my plate production. Oh, you son of a gun. One or more of the selected vectors on the layer. These vectors have been deselected. Okay, hold on a minute. It does not like evident multiple vectors. I don't know. Okay, one more time. Let's go into plate production. There we go. Now, in here, for some reason, toolpath options, create toolpaths is grayed out, which, you know, not sure what the reason for that would be. I want to have this step over 1/8 of an inch all the way around, and calculate. So I assume that we're going to have to, I'm going to have to learn more about it, because again, I haven't used it in 8 years, never used it, never even looked at, this is the first time looking at it, never looked at it, because it's like printing labels, and I don't need to print labels, but I think Kurt was the one that asked. That's as far as we can get on this today. All right. All right. Where did you pull the plate layout box from? I drew the box. I drew the box. That's 7.5 by 2 1/4 box. And then the plate production is here. All right, so I'll have to play with that some more. I'll create some plates, and I'll see why they're coming up blank. See if they actually carved, like if they show blank, but they actually carved based on what's written in the variable box. Possibly, because that's how labels do. I'll find out more, and in part 2, we'll go from there. I believe it was Kurt that asked about that. Kurt, that's as far as we can get on that one today, because, again, I don't know anything about it. And we have to move on, because we've got big fish to fry right now. All right, guys and girls, it's 9:31. For the next 15 minutes, I got 3 drivers out of date. For the next 15 minutes, we're going to be talking about modeling for a moment. And this, what I'm about to say, the first 10 of this 15 minutes, Desktop Pro and Aspire, it all applies, okay? I'm just opening Aspire because when I go to the section 2, one of the features is going to be an Aspire feature. Now, when we create a new project, we have this model resolution here. Now, by default, it's set to fastest, okay? Standard. Let me put something on it. Let me make them a little bigger. All right. Now, resolution, when you're setting up a job, resolution has to do with however many pixels it took to generate this 3-dimensional item. And currently, the standard resolution takes 1 million pixels. The high resolution takes 2 million pixels. The very high resolution takes 4 million pixels. Now, beyond these 3, we have 2 hidden resolutions. And to acquire them, you can either do it at the beginning or you can do it in here. But you have to hold the Shift key. If you're inside the program already, you hold the Shift key and click on the Create Jobs or Set Job tool. And then you'll be able to see those two hidden items. The extremely high uses 8 million pixels and the maximum uses 16 million pixels. Now you can access that right out of the gate when you are first setting up your job. If you hold the shift key down when you click on create a new file, when it opens up the file creation dialog, it will have those extras in there. If you had forgotten to do that, you can just hold the shift key when you reopen the dialog box. Like if let's say I set this to standard and I'm in here and I went, oh, I forgot to set it high. I can just simply hold the shift key and reopen the job dimension setup box, and I can go back and make that adjustment. Right? Now, when you purchase models or models that come with the software and everything, this is important. Okay? You want to try to purchase models from a reliable source where the resolution of the model is of high quality. The model is created of a mesh and triangulations. So there are extrusions and triangulations, and then that triangulation is, there's a mesh, a skin put over it of these little triangulations, and there could be thousands and thousands and millions of triangulations, depending on how high resolution the image is. But some of them models are called low poly models, meaning they're low resolution. And when you import the model on a low resolution model, when you import it, you can see, and this is not a low resolution model, this is a pretty decent one, but in low resolution models, when you bring it in and you're looking at it, in the 3D view, you can see little triangles under the surface. You can see the triangulation. It's a low poly model. It's very low quality and everything. It's not smooth. You know, it's not smooth. You actually see this triangle connected to this triangle, connected to that triangle, connected to that triangle, connected to that triangle. And you see those triangulations. You see those edges and everything in a low poly or a low resolution model. Now, if you happen to buy from Etsy or eBay or something like that, and you buy a model and the creator is just not that good, and he didn't make a high resolution model and it's a low resolution, you cannot increase the resolution of a model. Now, just because I set the resolution in my software to extremely high or maximum, when I import that low quality model, whether it's Desktop Pro or Aspire, I bought a model offline, it's low quality, I didn't know, but hey, I import it in, it's not going to make it any better just because I have my extreme resolution set to high. You can't make a poor resolution model better. Now, what you can do is you can take a high resolution and turn it to shit. You can do the opposite. So you can take a high resolution model and open it up in a low resolution program, and it's gonna cause pixelation. I'm gonna show you that example in just a second. But depending on the resolution, if we go back and I'm gonna set this to a standard here, standard resolution and everything, you can see, hopefully you can see the pixelation in this model. You should be able to see the pixelation in this model. Understand that the pixelation will translate over to the quality of the finished carving. Okay? So if you know you're working with a model, or you're going to be working with a model, it has nothing to do with 2D designs. VCarves and all that stuff, resolution, model, 3D model resolution in the job setup, modeling resolution only affects 3D models, not anything else. But if you know you're going to work with a model in your project, you need to increase that resolution. Now, working with a very high resolution is satisfactory. It is fine. For the most part, it's going to minimize the pixelation. You don't always David, thank you, David. I appreciate you. This is David Pingles. Pingle. Did I pronounce it right? Give me a thumbs up if I did, David. Thank you for the super chat. I appreciate that. Now, Ron, did I thank you already? I think I thanked you already for the super chat. I appreciate that. The resolution, you don't always have to be at the extremely high 8 million pixels or the maximum 16 million pixels. Those have particular uses. Now, here's where the uses come in for me. If I'm working with a general model and everything, for the most part, the very high resolution choice, that's why I train all of the digital woodcarver owners, when they set up their jobs every day, they set their resolution very high so it becomes muscle memory for them. Okay? It becomes muscle memory for them. So if I'm working with a model like from VCarve or whatever and everything, very high is where I'm going to be, generally. Never going to be in standard, never going to be in high. Very high. Because again, pixelation translates to the quality of the finished cut. So imagine, I'm looking at the, here on the arms. If I am in a standard resolution, let this regenerate and everything, that pixelation around the eyes, the jaws, the teeth, God almighty, right? Now, if I come in and change that resolution, okay, I'm going to get better resolution here and everything. And if I go to the extreme, hold down the shift key, open that up, come over here to here, wait for it. Okay, you should be able to see a dramatic difference. I'm using the maximum resolution now. You should be able to see a dramatic difference in that resolution of this model from regular, high, very high, extreme high, and that kind of thing, right? So the quality of that resolution, the pixelation, the minimizing of the pixelation, that plays a major role because that pixelation translates over to the quality of the finished carving. Now, know this, when we're working in extremely high resolution, things are slower to generate the tool path, the carving of the tool path and all that stuff and the model calculation. If we're in the extreme maximum, 16 million pixels, it's going to take some time to calculate the tool path. Sit back, relax, enjoy, because it's going to take some time, right? Depending on, the detail and the difficulty of the model and stuff. But it's not as quick. That's why you see fastest, right? Basic standard resolution is fastest to generate, tool paths and previews. Slow, 3 times slower, 7 times slower, 20 times slower, 50 times slower, right? 50 times slower. So you are, to generate the tool path, to calculate the tool path, to generate the preview and all that, it's going to be 50 times slower than what it normally would be in your standard resolution. But the quality of the cut's going to be 50 times better, in a sense. Not really. Now, for me, I am always at a default of very high, 7 times slower, the third choice, not the maximums. Now, if I am importing a model that I purchased off of Etsy or something and everything, I am going to, my general setting is extremely high. When I'm importing a model that I purchased, I do not want to import a good model into a low resolution setting because it depixelates. And here's the proof of that, just so you can understand. Let's get rid of this. Let's hit cancel on that. Wait for it. Let's get rid of this. Delete. And Sturgeon, Kevin Sturgeon, Big Daddy Fish, you had asked last week what the blue box on the right was on a 3D model. I'll talk about that when I come back in with the 3D model. I'll answer that question. All right. On here, I'm going to set to standard resolution, lowest of lows. And I'm going to import a model. Now, I'm importing a STL third-party model file, so I have to orientate it and all that stuff. But in my downloads, I'm going to go into my model file here, and this is a model I have for a customer. Very simple, basic model for a customer, but it is a custom one that he wanted made. And when I import this, it's a third properly. Because some models, and let's talk about this since we're talking about it, some models might come in sideways or skewed. They might come in upside down. They might come in backwards, right? It all depends on where that creator was in his workspace when he created the model. It all depends on where that creator was in his workspace when he created the model. So how that model gets imported, the way it's positioned, we have to orientate it properly for us. Now, models purchased from me, like when I make models for customers, it's always a top orientation. It's always the top. You're looking at the top when it comes in. Now, if we're in the straight up and down the Z here, top means we're like if we're looking at the top down, like at our carving and everything. That's what we want. We do not want to be sideways or upside down or backwards or whatever the case may be. Right? Right. Cool. All right. So, orientate. Now, I'm going to size this down. I'm going to go 23. I'm going to click apply, and I'm going to center the model. Now, when I centered the model, it centered it like in my material. Now, if it was a two-sided model, two-sided carving, I'm going to flip carve one side of the model on one side, flip it over, carve the other side, and when it's all cut out, I've got a three-dimensional model. That's a two-sided model. I want it centered, right? I want one side, other side, right? But on a single-sided model, I want it above what's called the zero plane. So when I position this, there's a black line. Let's move over here so you can see. This black line is the zero plane. Currently, the zero plane is at the center of my model because I centered the model. I need to push the zero plane down. Slide bar goes all the way down so that my model is sitting. Let me get to it. So my model is sitting on the zero plane. One-sided models need to be above the zero plane. If not, hard for you and everything, and we don't want that. We want it above. So always slide the slide bar down on a single-sided model. Now, I'm going to click import, and I'm going to import this model in. Now, I'm going to click import, and I'm going to import the model in, which is it is in now. And we're going to get a little bit of buffering. A little bit of buffering because I'm working with this model. We're going to get a little bit more buffering when I go to 50 times higher, okay? So just understand that. Now, look at this standard resolution. Now, this is a high resolution model. My team built this model. And it's a high resolution model. But look at the pixelation when it's in the standard view. Right? That would translate over to the quality of my carve. My carve is going to be based off of that and everything. My detail and everything. So it's very, very important that we set the resolution accordingly. Now, I think I can just go back in and reset the resolution here without having to re-import the model. I don't know. I honestly don't know an answer to that one. So I'm going to do that. I'm going to reset the resolution. Let's try that again. Hold that shift key down. And I'm going to go to maximum. Now, when I click OK, we might get some buffering, so be patient with me and we'll come back. Okay. Now, I believe it has I'm going to re-import it into this high resolution because I don't, yeah, I'm going to re-import it. I don't think it regenerated it very well. I'm going to delete that. And I'm going to re-import into this higher resolution now. We might get some buffering. Be patient with me. Slide that slide bar down. If I get any buffering, it's going to be right now, so bear with me. Yes, Rodney, you can see the difference in the finish. Yeah, that's so that tells me right then and there, if you by chance imported your model into a low resolution and you wanted to change the resolution, re-import the model, because changing the resolution, it did not clean up the edges the way they should have been cleaned up. Okay, so David Lowell, man, thanks. I appreciate you. I appreciate that very much. I appreciate that super chat. So re-import the model right then and there. That's what it tells me. All right, so now I have a high resolution model here. You know, I can go carve it and all that good jazz and all that good stuff, right? Done deal. Now, let's talk about draft and everything. If I were to draft this model, since it's a whole component right now, it's one component and everything. I haven't built it. I didn't build it from scratch right now or anything, so I can't draft individual items like we did the sheriff's badge. When I draft, it's going to add a draft to all the edges. And what it's going to do, if I add a draft to this, and in some cases, you may want, instead of your edges to be straight up and down, sometimes areas might be thin and stuff, and adding a draft adds more meat to it. But also it adds a little bit of an angle, so when your bit's carving, it doesn't have to stop, raise up, and then come over. It can kind of ramp up and everything, and it does slightly, not a whole lot, but I mean over the grand scale of things a lot. It helps reduce runtime, right? Not saying draft everything, right? Because desktop and pro users can't add draft. You can smooth. We'll talk about smoothing in a minute, but you can't add draft. So adding a draft is only a Spire tool. And but if I were to add a draft to this visible model, and I'm going to go extreme, 30 degrees. It's going to, and I might get some buffering on this because it's going to take a little bit to regenerate this. It's going to look at all the edges, and I might get some buffering, guys, because this is going to be a lot of work on it. It's going to, I can see myself slowing down in the computer. It's going to on those edges, it's going to try to create that angle, that draft. So it's only at 4%. It's going to take a minute. It's going to take a minute. I don't want it, man, it's 9:54. I want this to kind of be the last topic. We'll continue 3D and everything past this, but I want to get past draft. Let's do this. We know that we need to be in a high resolution. We know that there's going to be a waiting period 50 times slower to do things in this high resolution. We know that. I'm going to stop the draft procedure. I'm going to reduce my resolution. I'm going to bring it down to a standard. The very high, not standard. The very high resolution just for now. Just so I can talk draft quickly. But, and you can see, we have, you can see the pixelation now, right? You can see the difference, right? Immediately. High resolution model, we can downgrade it, man. We can make it look like crap by bringing it into a low resolution environment. So just remember that when you buy a nice model online, you're like, oh man, change the resolution a little bit. But if it's already a crappy model, we can't make it better. Okay? You can't turn a pile of crap into a pile of roses. Into a bundle of roses. I don't know what the word is. That's not even a term. I just made that up. But anyhow, you know what I mean. All right, draft. If I add a draft to this model, now it's going to be a little bit faster. Not like rabbit fast, but it's moving a lot faster than it was. It was tortoise slow a moment ago. Now, if you now kind of get resolution, right? This first part, resolution, and how it affects your model, and knowing that the pixelation in your model translates over to the quality of the finished carving, is that something, is that a little bit of tidbit of information that you didn't quite know or didn't quite understand? Did it help you any? Is that something you're going to look at now in the future when you're working with your models? Turn that resolution up so you get that high quality carving and everything. Now, that 50 times slower and all that, that's not carving time. That's just in the software. How long it takes to generate the three-dimensional image and the preview and the calculations and all. Your carve time is going to be your carve time based on your bits and everything. We'll talk about that in part 2 of this. But if you get it, if resolution now, hey, now, all right. And that's Desktop Pro and Aspire. Anytime you're working with a 3D model, resolution, get that resolution up, turn it up. Even if you go the 7 times higher, the third option, even if you do that, hey, do it, right? But for me, I kind of always work with the extreme. I don't go the maximum. The maximum when I'm building a model that I'm going to sell, when I build a 3D model that I'm going to sell to someone, I use the maximum resolution, that 16 million pixels and everything for that model. Now, so what you should be able to see here is on all my edges here, I now have this 30-degree draft. On all of my straight edges where I had straight edges and everything, I now have this draft and everything. And on my letters and stuff, I have this draft, right? And we've taken this straight up and down text, if you will, and we've drafted it out, right? And give it a little bit of an angle. Now when my bit's carving, my bit can, because the finished cut rides the bottom of the cut. It doesn't make passes. It rides the bottom of that detail cut. It only raises up and down based on the design, right? And if it has to kind of stop or decelerate to a point to where it's got to raise up on a flat edge, then to carve and then come back down and everything, versus ramping up, like, just ramping up, even at a slight angle, it can ramp up, more of an angle can ramp up and things. That increases that runtime. It doesn't have to decelerate that much and everything from there. Okay. All right. What is the smallest bit you can use? Well, I mean, you can get down to micro bits and everything if your router will hold the shank and everything, or if you have a reducer and all. But for carving, general carving, 1/8 inch tapered ball nose is a go-to bit standard, when there's not a whole lot of detail. So on this model, okay, I'm going to create a tool path, a finished tool path. And I'm going to use an 1/8 inch tapered ball. Now, that 1/8 inch tapered ball, in the areas it cannot fit, your ball bit has tool grooves, it has flutes, it has cutters all the way around that ball and everything. And you'll see in your preview little lines and stuff where the radius areas and all where that bit can't fit. So it's going to carve what it can, and where it can't fit, it's not going to carve. So the detail's not going to be that great. If I go down to a smaller bit, 1/16 inch, now I've reduced the diameter by half of my, of my 1/8. I've reduced down by half. Now I can get down even further. From there, I can go down to a 32nd inch with a 64th radius and get really fine detail. Now for me, that's my cutoff. 32nd inch bit is the cutoff for resolution. That usually gets me as much detail as I could ever want in a carving. But they do make smaller, finer bits. They do. They're out there. They're that's crazy, the kind of bits. But for standard, everyday, you and I out in our, shops, carving signs that, we might sell at whatever, 1/8, 1/16, 32nd inch tapered ball nose. That would be that's it. That's your highest detail. But that's it. Yeah. So I'm going to go with just a 3/16 inch or 1/8 inch bit here, right? And I'm going to add in the 16th, and I'm going to calculate that. That's going to generate 2 tool paths for me. So let that calculate. I'm using the model as the boundary, and by using the 2 tool paths in the same scenario here, my 1/8 inch bit would actually run first and carve what it can. Then the 16th inch bit would come back and do the rest machining, meaning it would do the rest of the design where the 1/8 inch bit couldn't fit. I could throw in a 32nd in there too and have a 3rd bit to do the finish. Now, for you guys and girls that have older Vectric software, I believe it was 10.5. I believe it was 10.5. And someone correct me if I'm wrong if you know the answer to this. I believe it was version 10.5 where it allowed you to use multiple bits in your finished cut. I believe before that, you could only use 1 bit. It's either going to be the 1/8 inch bit, 16th inch bit, what have you. It wouldn't let you do the rest machining procedure. I mean, in Aspire, you could create a rest machining process. There was a little hoops to jump around. You could do it, but it wasn't built into it like it is now. And so older software only has 1 tool. So you choose the 1/8 or the 16th, which one is going to be. The newer software, you can add multiple bits and you can run them in order to get that detail. So let's take a look at this tool path. Okay, so we're going to look at the 3D finish cut first. Preview the visible toolpath. Now I wasn't paying attention. I wasn't paying attention when I was calculating the toolpath, but this is going in an offset manner, round and around and around. I'm going to plead with you. When you have a program or a project with detail in it, do a raster back and forth like a printer and raster with the grain. If your grain on your board is running along the x-axis, raster is 0 angle. If your grain's running along the y-axis, raster at a 90-degree angle. If you've got, you know, like a burl or something, try a 45-degree angle or something where it's kind of doing both and everything. Right now, this offset is great for pockets and bowls and stuff like that. Don't get me wrong. But right now, this offset is going with the grain, against the grain, with the grain, against the grain, with the grain, against the grain, right? And I got all this detail and everything. And all that's going to do is on the against the grain areas, I'm going to have some sanding and cleanup and stuff to, you know, to deal with and all. And Kurt, thank you very much. Sorry to interrupt my train of thought there, but Kurt, thank you. All right, man. I appreciate you for that. All right. The offset round and round, I'm going to have some cleanup to do, and I do not want to have to try to sand in the detail of my 3D model to clean that up. If I'm carving with the grain, I'm going to get a much better carve with less finished sanding requirements. There's still going to be some. You can't get away from sanding. We as woodworkers can't get away from sanding, but it's not going to be like bad. This method that's happening right now, this offset method, I would never carve this way. I created the toolpath. You have to forgive me. I just hit calculate, wasn't paying attention, but you should raster on a model like this instead of offset, so you're carving with the grain, you get better detail and everything. Now, if I had a 3D model that was a bowl or something like that, where it was just, there was very little detail, maybe even, you know, I was about to say wavy flag, and no. A bowl where it's just easier for me to go around and around and down, you know, right? To create that and everything, and it's not that big of a deal. There's no detail or nothing I got to get in there. I could sand it smooth or what have you. Then offset's fine. It'll be a little bit faster and all that good stuff. But not in a model like this. This toolpath that you're seeing running right now, which is taking a long time because we're still at a high resolution, right? Do a raster cut. And Sylvia says, yes, newer software, you can use multiple bits. Absolutely. The newer software you can, older software you couldn't, and everything. Now, this is almost done. It's getting there. It's almost done. We're at 75%. So, and this, we're going to say goodbye after this, and we're going to continue the discussion. We're going to talk about bit choices more and things. We're going to talk about smoothing, how that affects our edges and what that does for us and stuff. And then we're going to be talking about photo VCarving and VCarve inlay. There's a lot of great detail. I'm hoping that when we're done with that class and the detail and the tips and things like that, that we'll see more of you guys and girls doing a lot of inlays in your cutting boards and stuff now that you'll have a better grasp on it and everything. So definitely. Now, let's get a vote going. Did we vote? Did I miss the vote? Or did I not? In the chat, are we waiting the following Tuesday, like the normal class day, or are we going to do it next Tuesday coming up? We're going to have a class next Tuesday to complete part 2 of this. Why wait 2 weeks when we can do it next week? I want your votes on that. And majority is going to win, right? Majority is going to be the winner. So let me know in the chat. Coming Tuesday or following Tuesday for part 2. All right. We're almost done, 95%, and I'm going to zoom in and we're going to run the last toolpath and show the cleanup and stuff and all that good jazz. Now, of course, I only created the finish cut. I didn't do the rough cut. This requires a rough cut. So all I'm doing is trying to get to the finish cut to talk about the 2 bits. But this cut absolutely requires, this particular carve requires a rough cut to hog away this waste material, because the finish cut does not make passes, ladies and gentlemen. It does not take passes down to the final cut. It plunges to the depth of the full model, and it rides that model to create the carving. So imagine if I did not rough cut this, that bit would be riding down, plunging, my ball nose bit would be plunging through this and would be burning itself on the edges and everything because it doesn't make passes, right? Now, let's get into a area that has some detail here. All right, can you see these marks here, right here and here? You can see it between the C and the U here and the R and, you know, on the edges and all. That's the software showing you the tool marks that 1/8 inch bit is making, because it can't really quite get down in to that detail. You know, it can't quite get down in. Sorry, that's a little bit too blurry. It can't quite get down in there, so it creates those tool marks and everything. On certain radiuses and stuff, you know, it can't get in, so it creates those tool marks and all. Now, let's zoom into here, kind of here, and let's run the finish toolpath, which is the 1/16 inch. And let's see if we can see real time it clean up just this general area. All right, so here we go. Preview the visible toolpath. Nope, sorry, selected toolpath. And watch as it goes through, watch around these letters and see if you can see if you can spot when it goes and cleans up that detail. It happened quick. It was quick, right? Broken, not burning. That's right, Rodney. That bit would be broken. The tip would be broken off on, especially if it was a 32nd and everything. So we want a rough cut. All right, let's see here. Next week. It was a majority rules. Part 2 next week. Next week, please. All right, so that's good. But did you see that? Did you see that the change from the 1/8 to the 1/16 inch bit? The cut quality difference. You see that 1/16 was able to get in there, right? And get that detail and everything for that, you know, finer cut. Now, imagine, in this case, I really don't need to go to the 32nd. The 1/16 is enough for the detail of this particular design. This is a very basic model, just a little plaque, you know, for like a school. Very basic, based on their logos and stuff. But the 1/16 would really be all I need for this cut and everything, for it to be a decent cut. I don't need to go with a 32nd inch bit. You know, I'm getting the detail I need from the 1/16. But some models have really fine detail. Eagles and things and dragons and whatever, you know. But some of them have really fine detail. And they are going to, that's going to be where the 32nd bit, you know, the smaller bit can get in that fine detail and clean up. And where the rest machining procedure, where you can use multiple bits, that's a bit of an advantage. So don't despair, ladies and gentlemen, if you don't have the newer software, where you have the older software where you can only use one bit. You can create a toolpath with just the smallest bit. Don't try to create, unless you have Aspire, there's a workaround for creating rest machining with multiple bits. But in Desktop and Pro, use the smallest bit for your toolpath. Don't try to create a toolpath with an 1/8 inch bit and then create another toolpath with the 1/16 and another toolpath with the 32nd. It doesn't work that way. All you're doing is carving the whole model with the 1/8. You're recarving the whole model with the 1/16. You're recarving the whole model with the 32nd. It doesn't do the rest machining. See, on this toolpath, the rest machining, what it is my 1/8 inch bit is doing a majority of the work here. My 1/16 inch bit is doing the rest of the design. It's only touching up the areas where my 1/8 inch bit couldn't get. That's rest machining. Okay? All right, we're going to hit save on this so we can continue next week. Save as. And we'll just call this, we'll go into the user's choice. And we're going to just say Academy. Academy sample model. All right, we'll save that. Now, next week, we're going to talk about VCarve inlays, normal inlays, deep inlays for like cutting boards and things like that. when we're talking about modeling, before we get into the inlays and everything, we're going to be talking about, we're going to show how to create a little quick models like patterns and stuff. Imagine if you would that you had a kind of a backdrop of some sort, that you were going to do a nice wooden backdrop, but you wanted it to look like a cushion of a chair or a couch or a fancy couch or something like that. I'm going to kind of teach you how to create a kind of a pin cushion model effect. It's not called a pin cushion, a button cushion, a plush cushion, couch cushion, whatever. I'm going to teach you how to create that pattern, and I'm going to teach you how to trim that pattern to a vector, like if it was kind of like an outline of a backdrop or something that you needed or what have you. So you're gonna see how to create models, and we're gonna see how to create this pin cushion with these little buttons and everything and seams. We're gonna see how to make that next week. All right, everybody. Until next week, we're going to finish here. I really want to, you super chatters, Kurt H. Hold on, before I leave, I got to, give me just a second here. Wade, Custance. Wade, thank you. Kevin Sturgeon, Big Daddy Fish, man, always appreciate you. Brooks Martin, Richard Brooks, Roger Brown, appreciate each of you. Doug Fushi, thank you, man. Doug the Doll, appreciate you too. Ron Chalmers, give me a thumbs up or down if I've mispronounced that one. Chalmers, Ron, thank you so much. I appreciate you. David Pingle and David Lowell, Kurt H. You guys, the super chat, that helps me out. It helps the channel. It helps me out so much. I've got website fees are coming due and everything, so that helps support the website and all that. Thank you so much for that. Those donations, greatly appreciate it. Everybody that stuck with me this long, all you viewers, thank you. I love you very much. I appreciate you. Come back next week, Tuesday, 7:15 p.m. This coming Tuesday. We're going to complete part 2, where we talk about a little bit more about 3D modeling. We're going to talk about smoothing and stuff. We've talked about resolution, how that affects the carve. Now we talked a little bit about drafting. We're going to kind of conclude drafting and smoothing. And then we're going to jump over into, we're going to talk about photo VCarve a little bit. And then we're going to end with VCarve inlay and everything. So I appreciate each and every one of you. Thank you so much. Button tuck. That's what this cushion is called. Button tuck. Thank you very much. Who was that? Rodney? Thanks, man, for that. So we're gonna learn how to make that. Now again, it's an Aspire thing. It's a modeling and all that stuff, but it just shows some of the things that we can do with simple shapes and arrays and everything to create patterns, right? All right. All right, everybody. Thank you so much. Thank you, Super Chatters. I appreciate you all. Y'all have a wonderful day. We'll see you next week. Thanks, guys.